This lecture is the next section that we're going to cover in chapter 7, which is G, and that's adding or subtracting rational expressions. If you want to refer to your book, that's actually section 7.5. Now, this is something you need to recall when you're adding fractions. They must have the same denominator. And when they do, that's when you keep the denominator and then you add or subtract the numerators. So this is something you've seen before. Take for example, if you have say 7/8 minus say 3/8. So the minute the denominators are the same, all you have to do is keep the denominator, but you will subtract the numerators. So 7 minus 3 is 4. Okay, but if you leave your answer as that, you're still wrong because you have to reduce if possible. So that means you have to reduce 4/8 as 1/2, and that's where you stop. Okay, so this is what you used to do in fractions, except now we are dealing with fractions involving polynomials. So we are dealing with rational expressions. So take for example, let's start with something a little friendlier. If we have 8x over 3y, and I wish to add to x over 3y. Okay, so you notice the denominators are the same. So when the denominators are the same, that's when you keep the denominator and you add the numerators. So you're now looking at what's 8x plus x. So back to combining like terms. So x really means 1x. So when there's 8 and 1 more, that's 9x divided by 3y. Now 9 and x, they're not stuck, just as 3 and y, they're not stuck. So they're really just factors. Okay, so you can reduce them. So 9 and 3 reduces to become 3 and 1. And so the final answer to this question is 3x over y. Okay, let's look at something a little bit bigger. So let's try something like, what if I gave you 3x squared plus 2x over x minus 1 minus 10x minus 5 over x minus 1. So you notice that again, their denominators are the same. And so once they're the same, you're going to subtract the numerators. Except that you have to remember that this numerator is really a polynomial, and this is also a polynomial. Now if you recall about polynomials, when you subtract, you really have to distribute the negative. Okay, so that forces you to change the sign. So this is something that you've learned before. So remember, the minus is not really just for the 10x, it's for the 5 as well. So you do have to distribute the signs throughout. So what's going to look like is the first numerator is going to be 3x squared plus 2x. But the second numerator, because of the change of signs, instead of plus 10 will be minus 10. And instead of minus 5, it will now be plus 5. Okay, so when I combine like terms, I now have 3x squared minus 8x plus 5 over x minus 1. Now if you stop there, you're still wrong because you need to reduce if possible. So if you look at the numerator, it's a trinomial. Okay, so you have to try sum and product. The sum I'm looking for in this case is negative 8, and the product I'm looking for is 3 times 5, which is 15. So which two numbers will do the trick? Looks like negative 3 and negative 5 will work. Okay, so negative 3 times negative 5 is positive 15, and when you add is negative 8. Okay, so I'm using foiling, and I'm looking at what multiplies to give me 3. So it's going to be 3 and 1. So that's when I use two parentheses and I go, okay, 3x and x. 3 times something is supposed to give me negative 3. So 3 times what number will give me negative 3? So that's going to be negative 1. And 1 times what number will give me negative 5? So that means it's negative 5. Okay, and don't forget the denominator is x minus 1. Now that it's in the factored form, I think you can see there is a common factor right here, x minus 1 and x minus 1. So I can now cancel these away. Okay, and it divides out to become a 1. So the final answer to this question is really 3x minus 5. So remember, you have to reduce if possible. So sometimes the question is not that clear cut. Take for example, if I gave you, say, 2x squared minus x over x minus 2, and I have a addition, for example, and it's a 2 minus x here, okay, and let's say it's a 3. So what happens is, if you look at the denominators, they don't look quite the same, but they are opposites. These are opposites, okay? So when they're opposites, that's when I will switch the terms around and change the sign. So if you think about it, it's like this. Supposedly the first fraction you keep it as x minus 2, okay? But this denominator is the second one. I'm going to factor out the minus 1. So that's going to look like x minus 2. Because the minus x now becomes plus x, just as the plus 2 becomes negative 2. Okay, but this minus that I factored out is going to turn my sign to become negative this time. So what happens is, when you switch the denominators, the sign will change. So you notice that that brings you down to this line. Okay, so when you switch the denominators around, you will change the sign from a plus to a minus, or from a minus to a plus. So what is the purpose of the switch? Okay, so that now with the switch, the denominators becomes the same, x minus 2, x minus 2. Okay, so once they're the same, that's when you keep it, x minus 2. So the numerators is 2x squared minus x and minus 3. Okay, so before you stop, you do have to try factoring. So over here, the trinomial, the sum is negative 1, and the product I'm looking for is 2 times negative 3, so it's negative 6. And so the two numbers are negative 3 and positive 2. Okay, so 2 and 1. So I'm factoring this. So at this point, it's up to you whatever method you like to use. Okay, so I'm going to use 2x and x, and 2 times something to give me plus 2, I'm going to put plus 1. And 1 times something to give me minus 3, I'm going to use minus 3. So what happens is, after you factor, you notice that all of them look different. There's no way I can match them, and so that's it. Okay, so it doesn't mean that if it's factorable, that means there's something to cancel. Not necessary. Okay, so just factor it just to be sure, and if there is nothing to cancel, you leave it. Okay, so the big question is, what if the denominators are different? So what happens is, you notice in example 3, the denominators, they are different sort of, but they are really opposites. So I can apply this little trick where I switch them around and I change the sign. Okay, but there are some denominators that are totally different, so there's no way I can switch to make them the same. So that's when you have to think of the LCD. Okay, so this is the steps. Let me write down the steps. So the first thing you want to do is find the LCD. Okay, so that's why there was the previous section. And then what you need to do is take each fraction and rewrite. So take each rational expression and rewrite them using the LCD as the new denominator. Now remember this process. It is possible that as a result you might have to alter the numerator, okay, to be something else. And then what happens is once you get the same denominator on both, that's when you keep the denominator. Okay, and you add or subtract the new numerator. Okay, but don't forget to reduce if possible. Okay, let's look at some examples. Let's try this. If you have 3y over, say, y squared plus 3y minus 10 minus 6 over y minus 2. Okay, so what happens is you notice the two denominators are totally different, and so I need to do something, and that requires me to do the LCD. So first and foremost, for me to get the LCD, I'm going to factor the denominators. And in this case, y minus 2, there's nothing I can do. But for this one, this trinomial, the sum I'm looking for is 3, and the product I'm looking for is negative 10. So the two numbers that will work is positive 5 and negative 2. So it's going to be y plus 5, y minus 2. Okay, so now if I look at the two denominators, I think I can decide what is the LCD, right? And the LCD in this case is y plus 5 and y minus 2. Okay, so the decision is I'm going to make your denominator y plus 5, y minus 2, just as I'll make you y plus 5, y minus 2. Okay, but what happens is in the first fraction, you notice the denominators look exactly the same. So this is what I'm looking at. I'm comparing these two. They look exactly the same. So the numerator I'm just copying as 3y. There's nothing I need to do about it. But when I compare these two denominators, you notice that you're missing somebody. Okay, you only have the y minus 2. You're missing the y plus 5. So that forces you to multiply by y plus 5 to the denominator. But at the same time, when you do that, you have to multiply to the numerator as well. So now it will be 6y and 30. Okay, so 6y plus 30 is your new numerator. Now remember, don't factor it, because otherwise you'll be back to where you came from. Okay, so the purpose of doing this important step is so that now the two denominators are the same. Okay, and if they are the same, there's no need to write it twice. All you do is write it once. But you have to subtract the polynomials. Okay, and this is the part I hope you remember, that the negative that's in front is affecting not only the 6y, it's also affecting the 30. So what's going to happen is it becomes 3y minus 6y, but instead of plus 30, it will become minus 30. So what's going to happen is now that the terms are on the same platform, you can combine like terms, and that gives you negative 3y, negative 30, over y plus 5 and y minus 2. Okay, so just to be safe, you definitely should factor the numerator, in this case negative 3, and you end up with y plus 10. Okay, so after you factor and there's nothing to cancel, then that's done. Okay, so sometimes you can't just eyeball, because just in case you can factor and it does cancel, you're going to have to reduce. Okay, otherwise you'll be losing partial points. Okay, let's try another example, something a little bit bigger. Let's try, here, let's try x over x squared plus 9x plus 20 minus 4 over x squared plus 7x plus 12. Okay, let's try that. So x over, you're going to factor this. The sum in this case is a 9 and the product is a 20. So that looks like 5 and 4. So it's going to be x plus 5, x plus 4. Do the same with the other one. So the sum here is 7 and the product is 12. So the two numbers is going to be 4 and 3. So that comes out to be x plus 4 and x plus 3. Okay, so this is where you have to make a decision. and the LCD in this case is all the different factors, and you take them all, okay, and the highest exponent if you have a choice. So my LCD would be x plus 5, x plus 4, and if you look closely, you also need the x plus 3, okay, so you need them all. So that means your decision now is to make the LCD x plus 5, x plus 4, as well as x plus 3. Same here, x plus 5, x plus 4, and x plus 3. So this is where you have to do the comparison, okay? So this is where you compare and see what are you missing. So you notice you are missing x plus 3, okay? So if you miss an x plus 3 for the denominator, then make sure you do it for the numerator as well. So the x is going to be multiplied to both, which means it becomes x squared plus 3x. Now if you look at the bottom, the other fraction, you notice this time you're missing, again, you're supposed to compare, right? And you have the x plus 4 and the x plus 3, so you're missing the x plus 5. So make sure you do that to the top as well. So 4 times x is 4x, and 4 times 5 is 20. So notice that in this whole process, I totally disregard the negative sign that's in front of the fraction, okay? Because we don't have to deal with it yet. Now that the denominators are the same, that's when you write it one time, x plus 5, x plus 4, x plus 3, okay? And if you look closely, there is a polynomial in the front minus a polynomial in the back. So remember, when you do subtraction, you have to change signs for the second polynomial. So the front one is going to be x squared plus 3x, and this minus, watch out, is not just for the 4x, it's also for the 20. So it's going to be minus 4x minus 20. Okay, so this is where a lot of students will mess up, so I hope you're not one of them. And so what happens is the denominator is x plus 5, x plus 4, x plus 3, okay, but the numerator is going to be x squared. 3x minus 4x, that's minus x, and then minus 20. So this is a trinomial, so you're going to have to do sum and product. The sum is negative 1, product is negative 20. So the two numbers that will work is negative 5 and positive 4. So it's going to be x minus 5, x positive 4. And in the denominator is x plus 5, x plus 4, and x plus 3. Okay, so now that it's in the factored form, I think you can see that there is one pair that reduces. Okay, so what is the final answer that will give you the full credit is when you have x minus 5 on the top. The x plus 4s are cancelled away, but there's still an x plus 5 at the bottom and an x plus 3 at the bottom. Okay, and remember, plus and minuses, they don't mix. Alright, so you can't cancel those, so that's where you stop. Okay, so let's get you to try some problems from your book. This is found on page 329, and this is from section 7.5. So let me give you the numbers. Let's try 37, 45, 53, 63. 1, 2, 3, 4. Let's do one more. 75. Okay, so can you try these problems? If you have any questions, we can discuss in the class. Alright? Okay, good luck. Have fun.